In this problem, we need to show that the ratio of sine of x plus y to that of sine of x minus y is equals to the ratio of tangent of x plus tangent of y divided by tangent of x minus tangent of y. Let us begin. So here we'll start from the left hand side. On the left hand side, we have sine of the compound angle x plus y. And in the denominator, we have sine of the compound angle x minus y. Now what we can do, we can use the fact that whenever we have sine of the compound angle A plus B, then it expands to give us sine of angle A times cosine of angle B plus cosine of angle A multiplied to sine of angle B. Now, if we have sine of A minus B, then we will have sine of A times cosine of B minus cosine of A times cosine of B. So let's use this particular formula. So in the numerator, we can have sine of x times cosine of y plus cosine of x multiplied to sine of y whole divided by, now we have sine of x minus y, so this is going to be sine of x times cosine of y minus cosine of x times sine of angle y. Fine. Let's do one thing. Let's divide both numerator and the denominator with cosine x times cosine 1. The reason is why we're doing this, because in the first term of the numerator we have sine x times cosine y. What do we want is we want to convert it to tangent function. We know that the tangent function is the ratio of the sine to the cosine function, so we need to get rid of this particular cosine y. So let's do that. So we're going to have sine of x times cosine of y. We're going to divide it with cosine of x times cosine of y. Doing this to the second term as well, so we have cosine of x times sine of y. We're going to divide it with cosine of x multiplied to cosine of y whole divided by, so we're going to divide the two terms in the denominator with cosine x and times cosine y as well. So we're going to get sine of x times cosine of y divided by cosine of x times cosine of y minus cosine of x times sine of y. So this will be divided with cosine of x times cosine of y. So there will be a couple of terms that will get factored out. So here cosine y will get factored out, cosine of x will get factored out in the second term of the numerator, and in the first term of the denominator we have cosine y factoring out, and in the second term cosine x factoring out. And finally we have sine over cosine, so this ratio is the tangent function, so we have tangent of x minus sine y over cosine y, that ratio is tangent of y. Similarly in the denominator we have sine x over cosine x, so that's going to be tangent of x. This is positive, minus we have sine y over cosine of y, so that's tangent of y. And this is the expression on the right hand side, hence proved.